This is part 2 to standard normal probabilities. We were given a problem with several parts, and in this video we are strictly going to go over part A, and in the third video in the sequence we're going to do parts B, C, and D. So after this video, there's still one more to go to finish up this particular topic. Here we are in spreadsheet mode. I already have the parameters set up. So the first parameter that I want to just type in would be my mean. Now, depending upon whether or not it represents a population or a sample, the mean could either be mu or x bar. It doesn't really matter at this point, so we'll just type in the mean as is. The mean was 1060. The standard deviation on the original problem, 120. And for the first part, or part A, we're only concerned about the proportion of students who scored between 1040 and 1190. So in a problem such as this, we have two x values, and one of those in this case would be 1040 and the other one 1190, because that's what they are on the original normal curve. Because we're doing a conversion from an x-axis to a z-axis, and that's what really does all the work, and that's the behind-the-scenes work, what we do is we use the z conversion formula, otherwise known as finding the z-score or the z-value that corresponds to this x value with a mean of 1060 and a standard deviation of 120. It's a subtraction and a division. Basically, we take our x value, we subtract the mean, and then we divide that result by our standard deviation. You have to put the entire numerator inside parentheses. We have equals, open parenthesis, x value. Now, if I drag and drop down, do I want that to change? Yes, so I'm going to leave it just the way it is. Minus my mean. And that one I always want to be drawn from that particular cell. So I am going to put my dollar signs on that. Now I close parenthesis. Divided by my standard deviation, and that I always want it to be called from that cell. That's a static cell reference, so I'm going to add my dollar signs to that and press enter. And now I'm going to do the same thing for this x2 value. That's the hardest part of the whole problem. The rest of the stuff is stuff that back in the day we would just look up on a table, but you all have this already in a spreadsheet. We're going to come to this part in just a minute. I just want to point out what these values now mean. Remember, we have an x value of 1040, and that corresponds to a z value of negative 0.1666667. Here we have an x value of 1190, and that corresponds to a z value of 1.08333338. Before I go to the diagram also, let me explain something that hopefully will make sense to you. If I take a look at 1060, and remember, I brought that 1060 all the way down to 0. I just shifted the whole curve over. Since 1060 is 0, and here I have an x value of 1040, my question, or the question you should be asking yourself is, does this negative z value make sense? And the answer is it should, because 1040 is to the left of 1060, just like negative any number is to the left of 0. Similarly, here I have an 1190, which is to the right of 1060, which means my z-value, this value right here, should be to the right of 0. And it is. Let's go back to the diagram. Here we are at the diagram. Take a look on the diagram. Here is 0, and just a little bit to the left of 0, that's where this line of the shading is. So that's negative 0.1666 whatever. And the other x value turned into a z-value of 1.083333, which is approximately right here. And now we're concerned about the area that's shaded in between these two. The spreadsheet will only give me values to the left. In other words, if I just pop in, say, this z-value, and I want to know how much area is under the curve, it will give me the area from here, or the proportion, from this all the way down, all the way into the tail, the left tail. And if I did the same thing for this z-value, I want to know the area or proportion. I'm going to use those interchangeably. It means the same thing. It will give me from this line right here, and it'll give me the entire area or proportion all the way down into the tail. One thing that I forgot to mention that's extremely important, the standard normal distribution, because it is a probability distribution, and it's a continuous probability distribution, the entire area under this curve, the entire area is 1, meaning 100%. Let's go back to the spreadsheet to see where this takes us. Here we are at the spreadsheet. I now have a z-value of negative 0.16667, etc. For this problem, I'm going to first find the area to the left of 1.08333333, etc. And in order to do that, I simply use equals. There's a built-in function within Excel that will give me the area that falls to the left of this z-value, all the way into the tail of the Gaussian curve, otherwise known as the standard normal curve. And that function is norm dot s dot dist for distribution. Norm dot s dot dist. And what we want to do is first click on our z-value. Now remember, I'm going to use the second one first, and there's a reason why I'm doing that. It's because the diagram, just the way I set it up on the diagrams, I did this one first, so I'm going to do it first here. So first thing it's asking for is the z-value, comma, and now it's asking me whether or not I want that to be cumulative. And the answer to that is yes. Unlike the binomial distribution, this one, or the standard normal distribution function, it will always be true that we want the cumulative value. And I close parenthesis and I press enter. Let me go back to the diagram. In the diagram, this is what that would look like. Here I have a z-value on the z-axis of 1.083333, And the value that the spreadsheet will give me when I look up the area to the left of that is this entire proportion. Let's check and see if that will make sense. I did mention earlier that half of all the data falls to the left of my mean, and in this case my mean is 0, and half falls to the right. So if I just asked you to guesstimate, give me an approximation of how much data is shaded in or what the proportion is to the left of this 1.08333, you would hopefully guess it's more than half, because just from the tail on up to this value, 0, would be half of it, and then this is actually a lot more. So if I were to guess, I would guess that it's something around, I don't know, that looks like 80% of the data. I'm not 100% sure. It might be a little more than 80% of the data. Let's go to the next diagram because I have the value put in over there. Here you can just see I have an x2 or an x value of 1190, which corresponds to a z value of 1.083333. And now that corresponds to an area to the left of z of, well, I kind of got it right. It was more than 80%, and that worked out to be 0.8607-ish. And if you take a look at this, that means that this represents about 86% of the data fell to the left of this z value, which, if we went all the way back to the original diagram, it would mean that about 86% of the students accepted scored less than an 1190 combined score on their SATs. Let's go to the x1 value. We would type in the same thing, equals norm.s.dist. Click on the z value, comma, do we want it to be cumulative? Yes, because the norm.s.dist is always going to be cumulative. Close the parenthesis, press enter, and what this is saying is that approximately, 43% of the data will fall to the left of negative 0.16667, blah, blah, blah. So let's go to the diagram and see what that looks like. As you can see on this diagram, we are to the left of 0 for this z value that corresponds to an x value of 1040 when you have a standard deviation of 120 and a mean of 1060. So this z value right here, now let me ask you this, if you were to guess as to whether or not this number would be more than 50% or less than 50%, I hope you would guess that it would be less than 50%. Why? Because 50% of the data falls from all the way out here in the tail on up to this 0 right here. Well, we have this little piece that's missing right here. So what that means is that it has to be less than 50%. I don't remember exactly what it was on the spreadsheet, but the next slide should tell me. And there we go. It's about 43.38%, or 0.4338 is the proportion of data that falls to the left of negative 0.16667. Let's go back to the spreadsheet and confirm that that's true. Yes, that's what it is. Now, as I said, we have an area to the left of one z-value and an area to the left of the other z-value. And how would we get the area in between these two, or these two z-values, I should say? In order to get the area between these two z-values on a spreadsheet, we simply subtract one area from the other, meaning here I have a larger area of roughly 86%, and here I have one of roughly 43%. So in this cell where I have it labeled as area between, we would say equals, click on the larger area, minus the smaller area, enter. Going back to the original problem, the number of students scoring between 1040 and 1190 at this particular college, which had a mean of 1060 and a standard deviation of 120, we know that the proportion of students that scored between these two values is approximately 42.68 or 69%. Let's take a look at the diagram. Okay, so what we have, the area to the left of the x1, then z1 value is 0.4338. We know the entire area to the left of 1.083 ended up being about 86% or 0.86. If I take this entire area to the left of this and I subtract this area right here, well, I pressed on it by accident. Let me go back, and I subtract this area here, I will be left with only the area in between. In other words, the area in between any two z-values is one of the areas minus the other area. So in this case, it's going to be 0.8607 minus 0.4338, and that gives me an area of 0.4269, which I already put in here. In other words, if I added this area up plus this area up, I would get back to that 0.8607. So let me physically subtract this area, and maybe you could see it better. There we go. The area in between ends up being 0.4269, meaning the proportion of students who scored between a 1040 and 1190 at this university was about 42.69% of the data. And by the way, notice I'm expressing my answer in different ways. I could also express it just saying, what is the probability that a randomly selected student scored between a 1040 and 1190? And you would just say the probability is 0.4269. If I asked for this as a percent, you would have to convert it to a percent, meaning that you would have to move the decimal point over 2 places to get 42.69%. No, that's not going to be too difficult for you, just wanted to point that out. Be sure to check out the next video where we'll be going over parts B through D.